Hello students, myself Professor Anusha Ekbote, Department of Physics, KLS Gokte Institute of Technology, Belgavi. I am here to help you to solve some typical CET questions from modern physics. Let's take the first question on de Broglie hypothesis. What will be the ratio of de Broglie wavelength of a proton and alpha particle of same energy? We are with the option 2:1, 1:2, 4:1 and 1:4. Let's see the solution for this problem. We know that de Broglie wavelength of a particle with mass m and energy E is given by lambda equals to h upon square root of 2m into E. Now we can write the wavelength for a proton as lambda p equals to h upon square root of 2mp into E. Similarly, we can write the equation for wavelength of alpha particle as lambda alpha equals to h upon square root of 2m alpha into E. It is asked to find the ratio of lambda p to lambda alpha, and it is given that energy of both these particles is same, but the mass of proton and alpha particle are different. When the energy is constant, lambda is inversely proportional to square root of m. Hence, when we take the ratio of wavelength of proton to the alpha particle, it will be equal to square root of mass of the alpha particle divided by square root of mass of the proton. We know that mass of the alpha particle is 4 and that of proton is 1. By substituting the value, we get the answer as 2 divided by 1, which is nothing but lambda p divided by lambda alpha is equal to 2:1. Hence, the correct answer is A. Let's see one more problem on modern physics. A pulse of light of duration 100 nanosecond is absorbed completely by a small object initially at rest. Power of the pulse is 30 milliwatt and the speed of the light is 3 into 10 raised to 8 meters per second. The final momentum of the object is, we are given with 4 options. Let's see how to solve this. First, let us write down the given things. Pulse duration is given 100 nanoseconds. Power of the pulse is given 30 milliwatt. Speed of the light is given 3 into 10 raised to 8 meters per second. We need to find out the momentum of the object. Let us understand the problem clearly first. We know that momentum of the object depends on the energy of the incident light. This can be understood better by this diagram. When the light of some high energy falls on the very small object, light imparts its energy to the particle, which is seen as the momentum of the particle. Hence, the energy of the radiation is directly proportional to momentum of the particle, or momentum of the particle is equal to energy of the radiation divided by velocity of the light. We know that energy of the radiation is not given directly, it is given in terms of power of the pulse and its duration. Hence, energy is nothing but power into time. We substitute the values for power of the radiation and time duration of the pulse and the velocity of the light. Our answer is 1 into 10 raised to minus 17 kg meters per second. Hence, the correct option is B. Let's take up one more problem on modern physics. Mass numbers of the elements A, B, C and D are 30, 60, 90 and 120 respectively. The specific binding energy of them are 5 mega electron volt, 8.5 mega electron volt, 8 mega electron volt and 7 mega electron volt respectively. Then in which of the following reactions energy is released? We are given with 3 reactions. D is forming 2B, C is forming B plus A and B is forming 2A. We are given with 4 options. Option A is energy is released only in first reaction. Option B is energy released is in second and third reaction. Option C is energy is released in 1 and 3 reaction. Option 4 is energy is released in all 3. Let's see how to solve this. Let us write down the given things first. Let's copy mass numbers of all the elements and also their binding energies. We know that energy of an atom is equals to mass of its constituent particles into its binding energy. Also, energy released in any reaction is equal to energy of the products minus energy of its reactants. Energy released in first reaction where it is giving rise to D to 2B is calculated as follows. E1 is equal to energy of 2B minus energy of D. Energy of 2B is nothing but 2 into mass number of B, that is 60, into 8.5, that is its binding energy, minus the energy of D, which is the mass number of D is 120 into its binding energy is 7. When you substitute the values for all these and calculate, we get the answer 180 mega electron volt. Similarly, energy released in second case where C is forming B plus A, we get E2 is equals to mass number of B into its binding energy plus mass number of A into its binding energy minus mass number of C into its binding energy, which is equal to 660 minus 720, which is equal to minus 60 mega electron volt. Similarly, energy released in third reaction, that is B forming 2A, can be calculated as E3 equals to 2 into mass number of A into its binding energy minus mass number of B into its binding energy, which is equals to 100 minus 510, which is minus 410 mega electron volt. When we compare all these 3 equations, energy released is positive only in the first reaction since it is positive, and in the other 2 reactions it is negative. Energy is not released here, it is absorbed. Hence the answer B is correct. One more question on Bohr's atom. The radius of second stationary orbit in Bohr's atom is r. The radius of the third orbit will be r, 2.25r, 9r or r by 3. Let's see how to solve this. We know that radius of nth orbit in case of Bohr's hydrogen atom is Rn equals to R0 into n square, where Rn is the radius of nth orbit, R0 is radius of first orbit, and n is integer which takes the value 1, 2, 3 and so on. Let's write down the given things. R2 is given to us as capital R, and following the above equation we can write R2 as 4R0. Hence 4R0 equals to capital R. By this equation R0 equals to R by 4. We need to find out the radius of third orbit. So R3 is equal to 9R0. Substitute the R0 value which is got from R2, 9 into R divided by 4, which is equals to 2.25R. Hence the correct answer is B. Thank you.